Welcome to Module 3, which is our last module in the Plant Diagnostics class. In this video, we'll explore a specific piece of the diagnostic process in a bit greater detail. And although we're going to be working on trees in this video, you can apply many of the same steps in diagnosing other types of plants. The readings for this module are found in Garden Notes number 112, Systematic Plant Evaluation. So you'll want to read this Garden Notes in accompaniment to this video. So let's assume that we have already completed step 1 of the diagnostic process. So we've identified the plant. Now we're going to go to step 2, identifying the plant's problem. And while we are doing this, we are going to be using what is known as the systematic evaluation process. So there are 7 parts of this process, and they're listed on the screen here. We're going to go through each one of them. So the first step is to take a macro look, and that's kind of the big picture look of the plant itself. For example, here's a street tree that's planted in the strip of grass between a street and a sidewalk. There's a lot of chlorosis and branch death on one side of the tree, and that happens to be on the south side. And when we're walking around the tree as part of our process, and we notice that there's an area on the trunk where there's a huge amount of bark missing. And this also happens to be on the south side. Actually, this tree had been hit by a car. So what's so significant about finding the large amount of bark damage on the south side? Well, right underneath the outer bark is the inner bark, or the phloem. And this is the layer of conductive tissue that's responsible for moving the photosynthates or carbohydrates throughout the plant. Since it's gone, the roots, once supplied by the phloem, are now not getting the resources they need and are dying of starvation. Since the roots are dying, this is causing the damage that we're seeing in the canopy of the tree, because the roots can't function to get the nutrients and water to that particular section. As part of the macro look at a plant, we want to look at the pattern of damage, because this can be a big clue to the cause of the problem. When we see what appears to be a uniform distribution of a problem, it usually points to an abiotic cause. And a random distribution of damage generally points to a biotic or living cause of a problem. When we see a tree that's dying from the top down, we can usually suspect a root, soil, or water issue, and in the particular case of a tree, even trunk damage. Most likely, though, it's some combination of these factors. When we see the opposite happening, so death from the bottom up and inside out, you can usually suspect oxygen starvation issues. And hopefully you can see that the needles of the pinyon pine are concentrated at the top of the tree and then on the outermost part of the branches. Pinyon pines only need 12 to 13 inches of precipitation a year, yet it was planted in a heavily irrigated lawn, which needs way more precipitation than that. And by the way, the lawn is brown because the photo was taken in winter. It's really important at this point not to jump to conclusions. We've got 6 more steps to go before we're done. Step 2 of the systematic process is to take a macro look at the surroundings. So we've taken a macro look at the plant in question, and now we're going to expand that wider to include perhaps the entire landscape. Can you see the advantage of taking the macro look? The plants in this landscape look pretty healthy, except for that one tree to the right of the 2-story house that appears nearly dead. Looking at the lawn of an area can also give us a good idea of the soil condition that an unhealthy plant is growing in. Is the lawn thin and weedy, or is it lush and dense? So a visual evaluation of the lawn's appearance can sometimes help us evaluate soil conditions supporting the lawn and, of course, the plant in question. If you observe multiple species of plants that appear to be damaged, this usually points to an abiotic cause. Most insect and disease pests are plant-specific or plant family specific. So the dieback on the top or sides of several unrelated species says abiotic. Uniform distribution of a problem on multiple plants can be a big clue. If you were looking at this row of maples and they all had leaf scorch on the south side, then you'd want to take a closer look at what was happening on the south side of that row of trees. So now, what if you find random distribution? So one tree is impacted, but the others are not. That suggests something that is unique to that tree that's not shared by the others. And here's a picture of what this might look like in real life. Step 3 involves looking at the soil or the rooting area for these types of situations. You know, there's a lot of soil compaction in our landscapes. When we build housing developments, shopping centers, and so on, we need a firm base for those sidewalks, driveways, and foundations. So we compact the soil to firm it. And this is not the same soil that plants need for good growth. Soil compaction can cause roots to grow near or on the soil surface due to low soil oxygen levels. And then excess watering can contribute to the low soil oxygen levels as well. To get a handle on soil compaction, you can push a screwdriver into the soil in several places. You can also use a soil probe, which will actually pull out cores of the soil to examine it. And in this particular case, if you look at the right-hand picture, you'll see there's a layer of what looks like purchased topsoil over what was probably the soil surface after construction was finished. Where the two soils meet is called a soil interface. And when you find a soil interface like this, it tells you that water movement in the two soils is different and may be contributing to a plant's problem. If the plant you're diagnosing is a tree, step 4 will involve looking at the trunk. So you're going to be looking for the kinds of items that are listed on the slide. I also want to point out that when you're looking at the trunk, it should be fairly round, and if it's not, that could signify some kind of problem. Suppose while you're looking at a trunk, you find damage like we saw in the first few slides of the presentation. A rule of thumb is that when the trunk damage is 1/4 of the way around or less, it's considered a minor stressor. But when the damage is halfway around or more, the damage is major and the tree is considered to have no economic value. And in fact, it probably should be removed. And that's because the potential for growth is so impacted by that damage. Step 5 is to examine major limbs. So we're going to be looking for the items that are listed on the slide in front of you. Step 6 is to look at the smaller branches and twigs. And what we're trying to do here is get a handle on the typical annual growth and how much it's changing from year to year or not. So we begin by looking at the growth increments and about 6 branches minimum. And you do this from all different parts of the tree. If all of them look good, everything should be okay. But if there's variation in the lengths, you may want to look at more branches because what you're trying to do is determine what's characteristic of the majority of the branches. If you find great variation from year to year or in a particular year, ask some questions to help figure out what happened. So in a year when you have shortened growth increments, you might ask, was there digging or construction done in the rooting area that could have damaged the roots and caused the growth increments to shorten? After we check the growth increments, we want to take a look at other clues like you see in the list. Step 7 takes us to the foliage. If you see dieback from the top down, remember we're going to consider root, soil, and water problems. Dieback on one side of a deciduous tree tells you to look for factors on that side of the tree, kind of like we saw at the beginning of the video. And then in moist years, or where irrigation regularly splashes into the foliage, especially the interior of the tree or other plant, look for foliar disease symptoms. When we're looking at the leaves, we're going to be looking for the items that are listed in the slide. So to summarize this video, always take time to go through every step of the systematic evaluation process so that you don't miss something. This is the end of the modules on diagnostics. From here, you can complete the worksheet and then take the post test.